recording because there were lots of awkward pauses and silences last period. But you people are much better than they are, so here we go. Derivative of sine of x is cosine of x. Derivative of cosine of x, negative sine of x. Derivative of tangent is secant squared of x. The derivative of cotangent is negative cosecant squared of x. The derivative of secant is secant x tangent of x. And the derivative of cosecant of x is going to be negative cosecant x cotangent x. These you should memorize. All righty. Well, here we go. For the limit as h approaches 0 of sine of pi plus h minus sine of pi all over h is equal to -1, give the, quote, pertinent information found in this limit definition. Okay, so what does this mean? I'm going to quote a former student of mine who would always say, like, what does that even mean? When you see this, it means take the derivative, right? Right. Take the derivative. Okay. Well, what's my equation? This is the formal limit definition of derivative. My equation is going to be right here, but it's not sine of pi. It's going to be sine of x. The derivative of the slope at x is equal to pi. And we're saying that the value of the derivative at pi is -1. Well, why is it -1? Because my function is sine of x. And what's the derivative of sine of x? Oh, look right here. It is
cosine x.
It is indeed cosine of x. And what's the cosine of pi? -1. Hey, that's another thing you need to know. Trig values in the first quadrant, but that's okay. We were exposed to them all in pre-cal. You're probably going to use some excuse like COVID just erased all my pre-cal knowledge, but still, you got to know them. So if you don't know them, you might want to, if you're a rusty trig value in the first quadrant person, you might want to use the weekend to brush up on those. Okay, so here we go. Example number 1. Find dy dx for y equal to 3 sine of x plus 1. I'm going to take my derivative. So this is kind of how I think about this. I'm going to treat this 3 sine of x like a mini product rule. Product rule is first times the derivative of the second plus second times the derivative of the first. So I'm going to take my first term, which is 3, multiplied by the derivative of the second term, sine of x. Derivative of sine of x is cosine of x. And then the second part of the product rule is just 0.
What?
Why is it 0?
Derivative of the first.
What's the derivative of 3?
0.
Settle. And the derivative of 1
0.
is also 0. So I'm done.
That's the answer?
That is the answer. It's always good when we find the answer. So this one, I'm going to rewrite this as 2x to the -1 minus 4 cosine of x. And I'm going to do a little power rule on the first one here. So -1 times 2 gives me -2x to the, so I'm going to subtract 1. -1 minus 1 is -2. And then same thing here. Anytime, just like I did before, anytime you have a value, a numerical value in front of the trig function there, you can just bring it down like we did right here. And then I need the derivative of cosine of x, which is negative sine of x. And so let me clean this up a little bit. We got -2 x to the -2 plus 4 sine of x.
That's weird.
And don't look now, but I am on a roll. Here we go. Example 3. Every once in a while I take out the Porsche as well, but sure. Here we go. Here I have to do the product rule because it is not a number in front of my trig function, it's a variable. So I'm going to take the first term, which is x, multiply it by the derivative of the second. Doing the product rule, derivative of sine of x is cosine of x plus the second term, which is sine of x, multiplied times the derivative of the first term, and the derivative of x is
1.
Indeed, it is. Plus the derivative of tangent of x. Can we do it without looking?
Secant square
Highly
of x.
doubtful. I think you peeked.
I did.
Secant squared of x. Busted. And I'm going to leave it like that. Okay? Everybody okay so far?
How'd you turn? I don't know. How'd you get 3 terms out of 2?
Okay, because this x sine of x, I did the product rule. And the product rule, excuse me, says first times the derivative of the second plus second times the derivative of the first. So I have x times the derivative of sine of x, which is cosine of x, plus the second term, which is sine of x, times the derivative of x, which is 1. Makes sense. And technically I did that previously, but the second term there was 0 because I'm multiplying it by the derivative of the constant. Okay, well, in example 4, I'm going to do this 2 ways. And the first way is the long way. I have 7 over cosecant of x. I'm going to use my good friend number 2, the quotient rule. Why do you want to hate on the quotient rule? The quotient rule is Lodi high minus Lodi low over low squared. So I've got cosecant of x times the derivative of 7, which is 0, minus the high, which is 7 times the derivative of cosecant of x. Jacob, peek real quick and tell me what the derivative of cosecant of x is.
Negative cosecant x times cotangent x.
All right, and then it's over low squared. So I've got cosecant squared of x.
Why would you just split the cosecant?
What?
I did.
Oh,
These are equivalent.
Okay.
That's, I could write this as cosecant of x parentheses and then squared, or I could write it like that. Either one of those. So let me clean this up a little bit. My cosecant of x times 0, that's going to go away.
yeah.
This negative I could pull out and make it positive. So I've got 7 cosecant of x cotangent of x over cosecant squared of x. Well, that was the long way.
Wait, you can't take one out, can you?
I'm going to leave it like that in this way, but there is an easier way. It does require pre-calculus. I could change this to what?
It's sine over. 1
It's
over
7 sine of x.
No.
Right?
Yeah.
Now I'm going to take the derivative, bring down the 7. What's the derivative of sine of x? Cosine of x. Is this equivalent to this?
No. Yes.
Yes, it is.
Oh,
You just want to take my word for it, or shall we do like a
you can
trig identity proof?
You can split out the cotangent.
No, it's like Friday morning. We don't want to do trig identity proofs. That was pre-cal.
I hated that.
Why don't we just move on then? You can do the shortcut there if you want. Simplify it first and then take the derivative. Yes.
So that's like a little another like memorization thing that cosecant is sine.
Yes. You should know that 1 over cosecant of x is equivalent to sine of x.
Pre-cal. Awful.
All right. Well, let's move on to example 5. A body is moving in simple harmonic motion with the position given by s of t is equal to 7 cosine of t. Part A says find the velocity at any time t. So how do I get the velocity if they give me the position?
Derivative.
Derivative. I need s prime of t is equivalent to the velocity. All right, so I'm going to take the derivative of my position equation. I'm going to bring down the 7. Derivative of cosine.
Oh, I forgot already.
Oh, don't look. Negative,
Cos.
negative sine of t.
So when you do take the derivative, you know what you have to do.
I'm sorry, what?
When you take the derivative, you just change the trig function not to t.
Not the number? Is that what you asked?
Yeah, not the t value.
I understand what you're saying. For now, yes.
Wait, so did
That's
you,
correct. You do not change the t.
Did you just do like a mini product rule?
I did.
Is that negative?
Anytime you have a 7 or a number in front of the trig function, you can just bring that down.
Okay.
Then the derivative of cosine of t is negative sine of t, so I just move that negative out front there.
Okay.
Okay, everybody all right? Question? Part B says find the speed. How do you find speed? I was gonna say it's like a bus with Sandra Bullock and
Ooh.
Keanu Reeves, but you probably wouldn't get my obscure pop culture references. You people watch movies, right? I'm just saying.
You mean like
Anyway, sorry, I digress. Speed. How do we find speed? Absolute value of the velocity. So speed would be the absolute value of negative 7 sine of t. And that brings us to part C, which is find the acceleration of t at pi over 4. And acceleration is the second derivative of the position or the derivative of the derivative. So I would need to take the derivative of the velocity. So A of t is going to be negative 7. Derivative of sine of t is cosine of t, and they want me to evaluate this at pi over 4. So I've got negative 7 cosine of pi over 4. Oh no. Once again, pre-cal has reared its ugly head. What is the cosine of pi over 4?
cosine?
We give 0.
Wow.
Red 2.
Yeah.
Over red 2.
1 over red 2.
Square root of 2 over 2, or 1 over the square root of 2. Either one of those is fine.
You
Got
say
it.
it's negative cosine 2 degrees lower than cosine?
What do you mean?
It just
He's
goes
kind of
back.
asking the same question I did.
It goes back and forth.
What was your question?
I said, whether God is he still there?
Yeah.
Well, because if you go, the variable's still there because the derivative of sine of x is the cosine of x.
Just keep going.
And so it's just a different variable, which is t. So the derivative of sine of t is cosine of t.
So the degrees don't really matter in this?
They do if it is evaluated at a specific point. So in this case, if it's evaluated at pi over 4, I take pi over 4 and plug that in and evaluate it at that point.
You never go sine. Just go back.
What's that?
You just go back and forth between sine and cosine.
Yes. Okay, well, that brings me to my favorite derivative, It's-
Sure.
the third derivative, which is the jerk. Okay, so how many of you can drive a manual transmission? Can we drive a stick? All right, well, you're not borrowing my calculus Ferrari then, sorry, right? But my grandmother taught me to drive out in the middle of the pasture. When you're first learning how to drive a stick, probably go something like like that, right? So the jerk is the derivative of acceleration. It is a sudden it's a change, it's a rate of change of the acceleration, like a sudden stop, start of a car. It's also my favorite derivative because you can like make bad math jokes. You can tell that little boyfriend of yours, quit being the third derivative. It's nice to tell jokes that only literate math people understand, right? One of my former students made me a poster, had a big third derivative. I would just point, quit being a third derivative, but I had to take it down. Okay, so part E says find the jerk. Standing up in front of the room for example 5. All right, so I want J of t. And J of t is going to be the derivative of the acceleration. And acceleration, it's right here. I've got -7 cosine of t, so I'm going to bring down the -7. Derivative of cosine of t is -sine of t. So that's going to give me +7 sine of t for the jerk.
The derivatives are in trains to bounce back and forth.
For sine and cosine, yes, that is true. That is true. I think I really need a t-shirt that says something like, don't be a third derivative. We need to make that happen. Okay. Well, example 6, mixing in the old material. I guess it would be nice if the AP exam only covered the last section, right? Rotating volumes of solid, finding volumes of solid rotated about the x-axis, right? Nevertheless, I'm pretty sure it's cumulative. So annoying. We have to like remember stuff that we have learned previously. I don't get it, man. What's up with that? Well, let's do a little mini review here. Find the limit as h goes to 0 of cosine of pi over 2 plus h minus cosine of pi over 2 over h. Do you want it? Can we handle it?
No.
Put me in, coach. I'm ready to play. We're just going to sit on the calculus bench and like hand water to the starters, or are we going to get in the game?
I'll play kickoff.
Well, do you want me to work it, or do you want to try it?
What is it asking?
Like, what does it even mean? Well, that's a good question, Jacob.
I get the equation, but
Might I have to quote my former student again? Like, what does that even mean? Hold on, I guess I'll work it out for you.
I'll just start to do it. What did you get signed?
This means what? What does this mean? take
So the negative sign of the power
the derivative. Well, that's helpful, but what is my equation?
Here. One.
It's cosine of x. So f of x,
Sign.
f of x is equal to cosine of x.
1. No. No, I was
I'm so excited about the answer, but I hate to burst your bubble. It was wrong. Okay.
Well, not that yet.
No.
What's the derivative
Yeah.
of cosine of x?
Negative sine over pi over 2.
Negative sine of x. And we were evaluating that
Pi over 2.
at pi over 2. So what is the sine
This is where I said 1.
of pi over 2?
1.
It is 1, but the negative out front makes it negative 1. Well, that was kind of fun. How about we try? You want to try the next one?
I'll try.
The only correct answer is yes, coach. I got this. Put me in the game. Find the value of a so that the limit as x goes to a of tangent of x minus tangent of a over x minus a equals 1. We got it. Maybe we don't got it.
Oh, I just got
But we're going to try and get it.
So,
I need the little chart with the,
back of the paper.
no, not that one. The one with the like values.
Oh, that thing that was on like your prerequisite packet, that little chart, is that what you're saying?
Yeah, that one.
The one that I told you probably needed to know?
Yeah.
Okay.
No, that was an exaggeration. I don't
No.
really think you need to know things that we have learned previously.
This is pre-cal. Not as bad at this. Hold on. Let me think.
How about I help you out a little bit? You seem to be
I'm almost there.
struggling. Well, what does this mean?
Take the derivative.
We're going to take the derivative, right? It's not the formal limit definition of derivative. It's the
Formula.
alternate.
Alternate.
It's the alternate. What's my function?
X.
F of x equals
Tangent.
tangent of x. I know that because in the alternate limit definition, f of x is right there. And then I heard you flipping over your papers because you hadn't memorized your trig derivatives yet. So f prime of x is equal to
Secant squared.
secant squared of x. So this one's a little different from the last one because it's saying that my derivative is equal to 1. And that means I need to figure out some value of x that makes secant squared equal to 1.
I did that.
Well, how about we help ourselves out?
Look, you do it.
Why don't we write this as cosine squared of x equals 1? We don't like secant. We want to stay with the more familiar sine and cosine.
Oh, give me a minute. Let me do this in my head.
So what value of x? The denominator would need to be 1, right? Because then I'd have 1 over 1, which is equal to 1. So what value of cosine?
0.
Ooh, interesting. Hold on.
2
What's
pi.
the cosine? What's the cosine of 0? 1, and then I would square it, right? So that would work. Would pi work?
No. Maybe
What's the cosine of pi?
-1.
And then I square it, so that would also work. So would 2 pi work?
Yes, 2 pi works.
3 pi, 4 pi. I mean, there's literally like an infinite number of right answers because I didn't put any restrictions on the domain. how about we go for 0? And if we were doing this like for reals, I would probably put a restriction on the domain so that there's only one right answer instead of like an infinite number. Okay?
When you go from secant to cosine.
It's like before when we went from 1 over cosecant, which is equal to sine. That's one of your trig equivalencies, okay? 1 over secant of x is equal to cosine. All right, well, not gonna lie, that was kind of rough. That's okay though, we're gonna do a little bit more review here. Part C says determine if the function is continuous and or differentiable at x is equal to 0 when f of x is equal to 3x squared plus x for x less than 0 and 4 sine of x for x greater than or equal to 0. So let's check the continuity. And so maybe I should use my little handy duty continuity test. So the first step, does f of 0 exist? And the answer is yes, it does. What is f of 0? I'm going to take 0 and plug it into the bottom equation because that's where 0 is defined. That gives me sine of 0, which is 0 times 4. So f of 0 is 0. And the second part of the continuity test, I'm going to check the limit. So I need to see the limit as x approaches 0 from the negative side, which means I'm plugging in 0 to the top equation. That's going to give me 0 plus 0, which is 0. And I just found the limit as x goes to 0 from the positive side. That was also 0, meaning that this is continuous.
Wait. How do you do 4 sine of 0? Is it just 0?
It's the same as f of 0. I plug 0 in, and the sine of 0 is 0 times 4 is 0. Therefore, my limit exists. Therefore, my function is continuous at x is equal to 0 because f of 0 is equal to the limit as x approaches 0. So let me write that down. Therefore, f of x is continuous at x is equal to 0 because f of 0 equals the limit as x approaches 0. But wait, there's more. Because it also asks, is it differentiable?
No.
Well, how should we go about figuring that out? What does it mean to be differentiable first?
Slopes are the same.
Okay, it means there is a derivative, and if it's a piecewise function, we've got to check the derivative of the left-hand side and see if it's equal to the derivative on the right-hand side. So what is the derivative of 3x squared plus x?
6x plus 1.
Okay. And we want to set that equal to the derivative on the right-hand side, which is
Oh no. This is gonna be
4, bringing the 4 down, and then derivative of sine of x.
cosine.
Of x. What is x? It's being evaluated at 0. So I'm going to plug in 0. That's going to give me 0 plus 1, which is 1. And I plug in 0 for cosine. Cosine of 0 is
0. What?
1. Okay, and we multiply by 4. Is 1 equal to 4? No. Therefore, f of x is not differentiable at x is equal to 0.
You can still just look at the slopes though, right?
Yes, but you're dealing with a trig function and a polynomial function. So depending on what value you're plugging in, it's possible that they could be equal.
Okay.
Okay, so you need to show your work there and work out the derivatives on each side. All right, well, one more. Part D says find the equation of the tangent lines to y is equal to 3 cosine of x plus 4 at x is equal to pi over 2. And this is a problem from the calculus jungle because there is no calculadora allowed. So here we go. I need two things to write the equation of a line. I need the slope and a point. So let's get the slope. Take the derivative. Derivative of 3 cosine of x. I bring down the 3. Derivative of cosine of x is negative sine of x. And the derivative of 4 is 0. Now I'm going to evaluate it at pi over 2. And the sine of pi over 2 is it's 1, which means that my slope is going to be 1 times negative 3 or negative 3. Now I need a point. I have an x value. It's pi over 2. How do I get my y value? Oh, look, there's an equation right there for y. So I've got y equals 3 cosine of x plus 4. So y of pi over 2 is going to be 3 cosine of pi over 2 plus 4. And what's the cosine of pi over 2? 0, which means that y is 4. Now I can write the equation of my line. With me?
Hold on.
Cosine of pi over 2,
No, not the top.
right here.
Yeah, you found the derivative, right?
I did.
Then you plugged it in.
And I
to
plugged
get
in pi over
slope.
2. Correct. Sine of pi over 2 is 1.
Okay.
So 1 times negative 3 gives me a slope of negative 3.
Yeah.
So now I need to get my y value because I don't have that yet.
Oh, okay, I got it now. Wait.
So I'm evaluating x as pi over 2. So I'm plugging in pi over 2.
So we're looking for the b value?
Yes.
Okay, yeah, I'm good.
But I need the y to be able to do that. Okay. So y equals mx plus b. Y was 4. The slope was negative 3. X was pi over 2. And so I'm going to solve for b, moving this to the other side. So that's going to give me b equals 4 plus 3 pi over 2. So now I got y equals slope was negative 3, x plus b, which is 4 plus 3 pi over 2. That's the equation of my line.
Where do you get 4? 4.
Because the cosine of pi over 2 is 0.
Oh,
And so that makes all of this 0, so I have 0 plus 4. All right, well,